Hi, Calculus class. Here we are working on the 2008 question number 5. The topic is separate and integrate. On your free response quiz that you're going to have later this week, there are going to be 3 topics. There is going to be a table topic, where there's going to be a table and some answers to give. There's also going to be an FTC, Fundamental Theorem of Calculus, and then there's going to be a separate and integrate. So let's go ahead and look at what we're doing in this question. So part A basically asks us to create the slope field for these 9 ordered pairs. So what I did is I wrote down some of the ordered pairs, and I'm going to fill them in here. It's y minus 1 over x squared. So I already set it up to save time. I'm just putting the y here, and then the x here. So the y goes here, and the x goes here, and again the y goes here, and the x goes here. And I'm going to go ahead and do this. So on the top I get a 1, and on the bottom negative 1 squared is simply a 1. So 1 over 1 gives me a slope of 1. Here I get 0 over 1, which is a slope of 0, and then lastly we get negative 1 over 1, which is a slope of negative 1. So I'm going to first go to negative 1, 2 and make a slope of 1. And then negative 1, 1 and make a slope of 0. That's a horizontal slope. And then lastly here we get a slope of negative 1. Okay, so now I'm going to go ahead and do this whole line. Now you'll notice this whole line, the only difference between this line and this line is instead of the x's being negative 1, they're positive 1. So I'm going to go ahead and make all these x's a positive 1. So now it's 1 comma 2, negative 1 comma 1, 1 comma 0, and I'm going to make all these positive. Now the reason why I kept them all in the same place is look what happens. What changes? Negative 1 squared was 1 and 1 squared is 1. So nothing changes with any of these. So they're going to be the exact same slopes. Alright? The last one, well I tried to make them look the same. It's a little off, but I tried. Anyways, the last one, we're going to use these ordered pairs 2, 2, 2, 1, and 2, 0. So I'm going to plug those in. My y is 2, my x is 2, my y is 1, my x is 2, and my y is 0, and my x is 2. And this gives me a 1 over 4. This gives me a 0 over 4, which is 0. And then here we get a negative 1 over 4. That's already negative 1. Okay, so we get a slope of 1/4, so not as steep. A slope of 0, and then a slope of negative 1/4. Again, not as steep. And that's everything we're asked to do for part A. So part A is now over. And now we're at part B. A ton of points are here for part B. It's a separate and integrate. So let's go ahead and look at what we have. This is what we have, and they ask us, now they don't say separate and integrate. They say find a particular solution y equals. They want you to find, when you see find the particular solution, find y. That's when we have to separate and integrate. They're going to give you no points if you don't separate the variables. So the dy stays here, and you see this y minus 1? It's got to get to the other side by division, so it has to divide over here. On this side, the x squared is stuck on the bottom. It can't magically get out of the bottom. The x squared's down here in the denominator, and the dx has to multiply to the other side. Now, if you'll notice, I mean, it looks this way, and it's because it's true. These two just switch places. That one divided over, that one multiplied over. All right, that's separate. If you do not separate, you do not get any points at all. And now we're going to integrate. On the left-hand side, this is setting up to be a du over u. When you have to du over u, the antiderivative is ln of u. The reason we know it's a du over u is the bottom exponent is a 1, is 1 bigger than the top exponent. So let's go ahead and see what happens if we did u substitution with dy over y minus 1. The first thing we would say is the u is y minus 1, therefore the du should be 1 dy. And what do we exactly have on top? 1 dy. This is perfectly, you didn't have to put anything, offset anything, this is perfectly du over u. So the antiderivative of this piece is simply ln of u. Okay, so that's good. So on this side we have ln of y minus 1. On the other side, you go to take the antiderivative, and you might not be having a bunch of luck. So what you have to do on the other side is you got to bring that x squared to the top and call it x to the negative second. Okay? Once you do this, you can add 1 to the exponent and multiply by the reciprocal. And that's exactly what we got to make sure we do. So we bring it to the top and we add 1 to the exponent, multiply by the reciprocal, plus c. Again, I had to move this up to the top, so temporarily move that x to the top. All right. Now, before I plug things in, I'm going to plug things in as soon as I can because I'm already earning a ton of points, and once I plug in, I earn even more points. But before I do, I want to take this x to the negative 1 and bring it to the bottom. It's going to make life a lot easier. Okay. So now I'm ready to plug in to solve for c, and I'm going to use the initial condition f of 0 equals 2. So in other words, when x is 0, wow, I put those backwards. I'm sorry, I'm just copying stuff down wrong. F of 2 is 0, I apologize. When the x is 2, the y is 0. So the y is 0 when the x is 2. Okay, so let's see what happens here. First of all, we get ln of negative 1. And I want you to notice here that the absolute value has a job. This is insanely important. The absolute value has a job. It makes it positive, and then ln of 1 is simply 0. On the other side, we have negative 1/2 plus c, and we need to finish by adding that 1/2 to the other side. So we get 1/2 is c, and now that we know what c is, we're going to take that value of c all the way back here and plug it in. Once I've plugged in that c, I have earned almost all the points. Not all the points, but almost all. I've earned 5 out of the 6 points. The only other thing I have to do now is get ln by itself. So, from here, after replacing the ln, I'm going to e both sides. I'm making sure I'm on the right. Yeah, everything's on the right track. I'm sorry, just you got to make sure. Online, they do the answer different, which is fine. They get the same answer a different way. Anyways, e destroys the ln, leaving y minus 1. And on the other side, we have this. And I'm not going to break this up. I'm just going to leave it. Here's the important part. I go to get rid of the absolute value. The absolute value had a job. If the absolute value didn't have a job, you just get rid of the absolute value, no price to pay. But because the absolute value has a job, you basically have to put a negative 1 in front of this side, which means we're going to put a negative in front of this side. And now my final step is just to add that 1 to the other side, and I'm done. Sorry, I forgot to mention it this whole time. All of this is part B. Okay, so we are done with part B. Now let's go see what part C is asking us to say. And it's asking for the limit as x approaches infinity. Okay. So this is our y equals, this is our f of x, and part C is what's the limit. Okay. Oh my word. At the very end, I had a y minus 1 and I had to add the 1 to the other side. I don't know if I wrote that. How could I forget that? I don't know. I'm sorry if you saw that and you're like, stop, Mr. Pygott. That's the correct answer to part C. I don't know how I forgot to put the plus 1. My mind's moving. Okay, sorry about that. So that's the final answer to part C. And then the question for the next one is, well, what's the limit as x approaches infinity of this? All right, now very important. The important question is really, what's the limit as x approaches infinity for 1 over x? Put something infinitely large over here. What's 1 divided by, and just make this a huge number? What if I just keep adding zeros, what's this going to get closer to? 1 divided by something insanely huge is 0. Okay? So, when I go to plug in infinity, negative 1 over infinity is 0. So I get negative e. This piece is now 0, but I still have a plus 1/2 up here. And I'm pretty much done. I mean, you could, rewrite it nice and clear. But that's basically it. If you look online, they do something weird. You're like, how'd they get that answer? They put the 1 in front. And then they said, hey, that e to the 1/2, that's the same as the square root of e. But I would have left the answer just like this, or even like this. And it's only worth 1 point, but it's the last point, so fun to get. All right, thank you. Bye.